be solving systems of equations using substitution. There are two scenarios that we can have while solving a system that best makes sense. That first scenario is going to be when both equations are written in slope-intercept form, so y equals mx plus b. What this might look like with numbers is an equation such as y equals 3x minus 2 and y equals 5x plus 4. Now you might be saying, well, I can use graphing to go ahead and solve this, which is fine, you can, but you might not always have graph paper readily available. Also, when you graph, you might have an intersection point that might not fall nicely on the grid, for example, like 1, 2. It might be 2/3, 4/5, and it's very hard to predict what that looks like on the actual graph. So substitution is a better method. The second system could look something like y equals mx plus b, and so one equation in slope-intercept form, and the second equation written in standard form, which is ax plus by equals c. What that might look like with numbers, y equals 3x minus 2, and 4x plus 8y equals 32. So on this next page, I'm going to show you a couple of examples of both cases and how to solve by using substitution. So example 1 says solve the following by substitution. So I have y equals 3x and y equals x minus 2. So if y is equal to y is a true statement because it's the same variable. If y equals 3x and this y is equal to x minus 2, then they are equal to each other. So in order to solve this system, I have one equation with one unknown, so I'm going to solve for x by subtracting x to both sides. 3x minus 1x is 2x. X minus x is 0, so I have 2x equals negative 2. To solve for x, I'm going to divide both sides by 2, so x is equal to negative 1. Remember, your solution to a system is a coordinate, so x was negative 1. Now I have to find my y value. I tell my students, substitute into whatever equation looks easier. For me, that's the top one, so y equals 3 times x. But I'm not going to put x into the equation because I know I'm replacing it with what it's equal to. So I have 3 times negative 1 is negative 3, so y is equal to negative 3. So my solution here is negative 1, negative 3. In B, here I have one equation written in slope-intercept form, however x and y are switched, and one equation written in standard form. So I'm going to take what x is equal to and substitute it into x in the second equation. So x minus 2y is equal to negative 3. Again, I'm replacing x with what it's equal to. In this case, it is 3y minus 5. Again, that comes from x minus 2y equals negative 3. Combine like terms. So my like terms here are 3y minus 2y. That is equal to 1y. I did not use minus 5, so I bring that down. And that is all equal to negative 3. From here, I want to add 5 to both sides. So when I add 5, I get y is equal to 2. Substitute back into one of the original equations. I'm going to substitute into the top one. So x equals 3 times y. Put parentheses because I know what y is equal to. Minus 5. So 3 times 2 is 6. 6 minus 5. X equals 1. So my final solution here is 1, 2. In C, here I have an equation written in standard form, negative 2x plus y equals negative 3. And one written in slope-intercept form, so I'm going to replace y with what it's equal to. So negative 2x plus y. Again, y is getting in parentheses because we're replacing it with 2x minus 3. And that is all equal to negative 3. So now, in the parentheses goes 2x minus 3. And I want to combine like terms. So I have negative 2x plus 2x. Negative 2 plus 2 is 0. So the result is negative 3 equals negative 3. And you have to ask yourself, is this a true statement? The answer is yes. So my answer here is infinitely many solutions. Meaning any value for the variable that we pick is going to make this system true. I would like you to try the U-tries on your own. So you're going to go ahead and do the problems, hit pause, and when you are ready to check the solutions, click on the pause button again, and I will have the solutions ready for you. If you've done A correctly, you should have gotten 0, 2 for the solution. And for B, you should have gotten 4, 2 for the solution. In example number 2, more of the same here. The directions say solve the following by substitution. I have an equation written in standard form, an equation in slope-intercept form. The only difference is now I have a coefficient in front of both variables where I'll have to distribute. Kind of like what you had in the U-try for problem B. So I know what y is equal to, x plus 3, and I'm going to replace it in the first equation. So negative 3x plus 3 times y, again I get parentheses here, is all equal to 4. In the parentheses I'm going to put x plus 3. So now I'm going to distribute and solve. 3 times x is 3x. It is positive because of the plus sign. Positive 3 times positive 3 is positive 9. I did not use equals 4 or this negative 3x out front. So now if I combine like terms, negative 3x plus 3x, well that's eliminated because it makes 0. So I'm left with 9 equals 4. And again, you have to ask yourself, is this a true statement? And the answer is no. So your solution is no solution. In B, here I have the equation 7x minus 3y equals negative 23, and x equals 5y plus 15. So I'm going to take what x is equal to, 5y plus 15, and replace it in the first equation. So 7 times x minus 3y equals negative 23. So I'm going to put in the parentheses 5y plus 15 and solve for y. 7 times 5y is 35y. 7 times 15 is positive 105. Minus 3y at the end is all equal to negative 23. From here, I want to solve for y. Combine like terms. So 35y minus 3y is 32y. Still didn't use this plus 105 is all equal to negative 23. Subtract 105 from both sides. So 32y is equal to negative 128. Divide both sides by 32. A positive divided by a negative, a negative divided by a positive is a negative. 32 goes into 128 4 times. So my solution is some number, comma, negative 4. Plug back into one of the equations. I'm going to plug into the bottom equation here. So x equals 5 times y, which I'm going to put parentheses there again, plus 15. Negative 4 4 goes into the parentheses, so 5 times negative 4 is negative 20 plus 15. So x equals negative 5. So my final solution here is negative 5, comma, negative 4. Finally, in C, here I have 8x plus 8y is equal to 0. So if I want to solve for one of the variables, I know that x is equal to 2y minus 9. So I'm going to replace x in the first equation. So 8 times x, which is parentheses, plus 8y equals 0. In the parentheses goes 2y minus 9. And now I'm going to distribute and solve. 8 times 2y is 16y. 8 times negative 9 is negative 72. Bring down plus 8y equals 0. Combine like terms. 16y plus 8y is equal to 24y. Did not use minus 72, and that is all equal to 0. So add 72 to both sides of the equal sign. So 24y equals 72. Divide both sides by 24. And we get that y equals 3. Now substitute back into one of the original equations. So x equals 2 times y minus 9. So that's 2 times 3, which is 6, minus 9. So x equals negative 3. So my final solution here is negative 3, comma 3. Go ahead on the next page and try the U-tries. Hit pause, and when you come back, I'll have the solutions for you. So for A, you should have gotten 3, comma 7. And for B, you should have gotten 5, comma 3.